Hello everyone, my name is Easton Dias. Welcome back to my channel, and I have started a series in which I'm going to explain to students how to answer an interview, how to prepare for an interview, and what are topics you should prepare. And the topics which I have covered till now: main engine, generator, MIS generator, purifier, freshwater generator. Okay, so if you want to see the earlier videos, go through the description, or maybe you can go to my YouTube channel, find a playlist there, and you'll able to go through all these videos, and also some other old videos which are there. You can also go through them. But first, I will say go in this order. Okay. Now, before that, we had studied about freshwater generator, and freshwater generator produces water. Okay, the water which is produced, we are sending it to our tanks. It could be a wing tank, and these tanks are huge capacity tanks. Okay, they might be having around 200 tons, 300 tons, or 500 tons also. Now this water is there at a lower platform. We cannot send the water up. Okay, in our homes, what we have a tank on the roof, and PWD supply line will, with the pressure, it goes up, it fills the tank. We have one float valve which is going to cut off the water, and that water from that tank is taken through the help of pipelines, and that pipeline is connected to the taps wherever we require them. Whereas on ship, what happens is, now this tank which is there is down, and you have accommodation which is there on upper floors. Now you need to send the water up. Okay, and you cannot have pump running all the time. So what we have done, we have something called as a hydrophore. Now in the hydrophore, what exactly is a hydrophore? Hydrophore is basically a shell, or you can say a cylinder. Okay, now in this cylinder, it's a bigger size cylinder, not the cylinder which you imagine for LPG which you see, or for your CNG which you see. This is a bigger size cylinder, you can say. And in that, what actually happens is, we have water, and we also have some amount of air. Okay, now what we do, first we fill up water. Let's say we fill up water to 3/4, and then we pressurize air. We pressurize air to around 5 to 6 bar. Okay, so we pressurize air, the air is charged inside, and then we close the valve. Now the air cannot escape. We have lines provided which what they do, they take water supply from your freshwater tanks, whichever tank which is there. Mostly we'll have freshwater tanks to the port side, and we'll have freshwater tank on the starboard side. They will take fresh water from either of the tank, put it in the hydrophore. Now the hydrophore level will move up and down depending upon the consumption. Now because this hydrophore is pressurized, the outlet line which is going to all the lines in the accommodation, all the places in the engine room, it can supply water at any place with the same amount of pressure, because the air vessel which is there, or the pressure vessel which is there, which is holding this water and air, is pressurizing and sending it to wherever you open the valve. So whenever the water is consumed, the water level will start dropping. As the water level starts dropping, the pressure also starts dropping. The pressure starts dropping, your pump starts it. The pump is set on cut-in pressure. Okay, you might set it on 4 bar cut-in pressure. Cutout might be around 5.5 bar, or 5 bar, or 6 bar also. It depends on what you want to set. Okay, what your pressure can, what your pipelines can handle the pressure. Depending upon that, you'll set. So this is the way. What you do is, you have water being filled by the feed pumps. Okay, by the freshwater pumps, which are taking suction from the freshwater tanks, putting it inside your hydrophore, and the water level will move up and down depending upon the consumption. Now you'll be wondering why we require air when we have the pumps only putting water inside. Why we require air? Now if we had to directly supply with the pump, what would have happened if there was no air? Let's imagine what would have happened. When air is removed out of the equation, there will have been only water. And if we had to use water in a pressurized state, what actually happens is, the pressure rise and drop is very fast. Okay, water or any liquid cannot be compressed, so the pressure rise will be instantaneous. Whereas air, what happens, you can compress it, so the pressure rise and drop will be slowly. Now because of the presence of air, what will happen is, the pressure change which is there will be slowly. So when you're consuming so much amount of, let's say 500 liters of water, the pressure drop might not be that much. Whereas without air, if we had to just transfer even 1 liter, the pressure drop would have been huge, and which would have resulted in the pump cutting in, cutting out, cutting in, cutting out very very frequently, and would have damaged the pump. That's the reason the air is provided, so that the pressure rise and drop when the pump has started and when the consumption is started is less, because of which you can use that system, and you are not having a pump which is suffering because you're cutting in, cutting out. Now, if you have understood this concept, you can understand very well. Suppose the air in that system is lost, air in that vessel is lost, okay? Then your pump will start cutting in, cutting out very frequently. So if you see your pump cutting in, cutting out very frequently, that is the meaning that it directly tells you that yes, the air in that hydrophore is gone out. Okay. One more thing which is there, just because now you know that air is very good, doesn't mean you charge full air. Let's say someone charges to such an extent that the air level or the water level is gone down to the pump line. Now what can happen is that air can leak into the pump, and once it goes into the pump, it can cause problem for suctions. So that's the reason you cannot have too much air also in the system. You require water. Why you require water? Because you want that water to move down. You want you want the pump to start only after it has consumed, after it has given a lot of water. If your pump has to start after pumping, after supplying very less amount of water, then the system is of no use. Okay, so that is how the hydrophore works. Now what is there? That is about the cold water which we are getting. Now let's say what we want to know is, how about the hot water? Do we require geysers? No, we don't require geysers. What we do is we have something called as hot water circulating pump. Okay, now hot water circulating pump, what it will do? It is taking suction, it is taking water from this line, from the hydrophore outlet line, it is taking water, then it is sending to your calorifier. Now calorifier is the name given to our water heater. It's a big water heater. It could be electrical, it could be steam, it could be a combination of both. So this hot water circulating pump which is there, which is sending water to your calorifier, and the calorifier line goes to all the hot water lines which are there in the accommodation, and then it recirculates back to this line, back to this pump. Okay, so the pump will take suction either from the return line, or depending upon if the water is consumed, then it will take fresh water from the hydrophore outlet line. So that is how our water needs are met. Okay, and for drinking water, there will be another small tapping which will be going through your filter. It will be going through your UV filter if you have. It will go to your mineralizer. Okay, and then it will be passed, and then it will be sent to your accommodation wherever drinking water lines are there. Understood? Hope you have understood this video. If please make sure you like this video. If you are there till this point, please like this video, please share it with your friends. Make sure everyone comes to know, especially whoever is planning to answer interviews, and whoever even is studying JME or DME, whatever it is. I feel you should go through, understand the topics very well. If you understand the subject very well, it's very easy to remember, and it's very easy to answer in the exams. Okay, thank you.